Is my screen visible? Actually, while practicing Python, maybe sometimes we will get some doubts. For example, let's take while practicing. Actually, yesterday I thought about the this Gini index, entropy. What is why we are using Gini index? Why we are using entropy? But there might be chance to forget while practicing next times. After if you got the one project, you are using this decision tree after 5 months or 6 months. So there is a chance to forget this one. That's why I included those concepts in the Python notebook. If we, while going through this notebook, if you have any doubts, this information will useful to you. Here I gave introduction of the decision tree. We'll repeat again. Decision tree is the card. Card means classification and regression trees. So this is the machine learning technique which is used for the both classification and regression. But it is the tree structure, just like a hierarchical tree structure. At the starting time, what we consider all features, the data, entire data is the root. Then after, based on the which root have the in which independent variable have the high information, then we select that independent feature is the root. Then after, we'll split for the there might be for the categorical data how many different classes presented in that data, we will split that many distinct splits. Here we won't go through the binary split. How many distinct classes presented in the categorical data, based on that many distinct values, we will split. Coming to the numerical data. In numerical data, first what we'll do, we'll sort the all numerical values. Then after, we'll check what is the class. Then after, we'll check what is the class. For example, let's take 0 to 100. We have the three different classes. For the particular feature, that is the numerical feature. Let's take age. Age is what we consider 10 to 80. Here classes are three. Let's say whenever we are sorting 10 to 80 on ascending or descending order, whichever you want, you can just check whether the 10, 11, what is the class of the 10, 11, 12, 13, like that. If the class of the 10, 11, 12 are same, you don't split in between 10, 11, 12. Wherever our class changes, for example, let's say 10, 11, 12 are the class 0. These three data points dependent variable label is the class 0. 13, 14 is the class 1. Again 15 to 20, 16 to 20, class 2. What you need to do? You won't take breakpoint for 10, 11, 12. Why? Because these all are class 0. So whenever class changes, that is, it goes to the for 14, 15, it is the class 1. So you can split our data greater than or equal 10 and less than or equal 30. What is here? Here, actually, categorical data, maybe there might be 10 classes, or sometimes for the categorical, wherever after ascending all numerical values, that the feature all values into ascending order, we'll split wherever class changes, we will split there. Why? Because if we want to split distinct values in numerical data, what will happen? If we have the 10 to 90 values, but numerical data, there might be chance to decimal values, there might be chance to float values. There might be, for example, let's take, we have the numerical values 10 to 20, but there might be some two values, 14, 16 missed whenever the training data. If we have split 10, 11, 12, 13, 15, 17, 18, 19, 20. Whenever new data point, that is the test data, have the 14 or 16, at that time our model will feel confused whether this belongs to class 1 or class 2. If we are splitting like this, greater than or equal 10 or less than or equal 13 is the class 1, class 0, sorry. Greater than or equal 14, less than or equal 15 is the class 2. Again, what we have, the 16 to 20 is the class 2. So greater than or equal to 16, less than or equal to 20, that is related to the class 2. Again, 21, 23, 22 are the class 1. There might be chance to change class. So based on the wherever our class changes, you can take that range is the split. Split are the breakpoint. So like this distinct splits we apply for the categorical data and numerical data. So classification and regression trees, this is the, I already told you, this decision tree will applicable for the classification and regression. Here root node, it represents the entire population or sample is the root at the starting time. This further gets divided into two or more homogeneous sets. If the root attribute have the only two classes or two variations, then we will split it as a two. If it have the more than two classes or two classes in the time sense in the categorical data, what we call, for example, we have the 10 variations with 10 labels, we say. Don't think classes means the dependent variable. Just I am saying categorical different patterns. Okay, we'll say patterns. How many patterns are available in the categorical? That many homogeneous sets we will split. Homogeneous nothing but the, for example, whatever I said 10 to 12, that is the class 0. So all data points are related to this same class. That is the homogeneous sets meaning. Understand? That is the homogeneous test meaning. So whatever the 14, 15, that is the class 1. So the data points 14, 15, between the 14 and 15, all are related to the class 1. That is the meaning of the homogeneous set. All data points are related to the same class. There is another word, that is the splitting. It is the process of dividing node into two or more subnodes. For example, here we have the root node. After find out the root node, what we'll do, so splitting after, for example, we have the 10 features. We have taken for the feature which is high information that we have selected, that is the root node. Then after we have split based on that root node, we have splitted some 4 or 5 categories. Then after we need to include all features. Based on the single feature decision, we can't go through the whether the predictions of classification or the regression. What we need to, based on those split, we need to include other features. That type of splitting is we call as the subnodes. After root node, whatever the nodes we used for the splitting, those nodes are the subnodes. Decision nodes means when a subnode split into further subnodes, then it is called the decision node. For example, we have the 10 features. Let's assume we have the 10 features. In first, we have selected 2 or 3 features, or there may be sometimes one feature for the root node. Then after we have splitted some subnodes. But based on this root node and subnode, we are not able to conclude whether it is belongs to which class or other class. At the same time, we are not able to predict what is the correct price of the regression model using. At that time, what we need to do? We will subdivide it into the nodes. How many times we will subdivided those nodes? Till we achieve the correct classification, correct mathematical expression to predict the regression value or to predict the classification. Wherever we have take exact decision. For example, from the root node, we can't classify. From the subnodes, based on these subnodes, we are not able to give 90-95% confidence to predict the classification. At which node, after we are splitting nodes into the subnodes like this, we are going to the continuous process. At which node we are able to take decision correctly, then that nodes are called as the decision nodes. There is the another terminology, that is the leaf and the terminal node. Nodes that do not split are called leaf or terminal nodes. For example, we have the 10 features. We have splitted all features. It's not possible to split more than that. At that time, those under of the tree, what are the nodes presented in under end of the tree? We call those are the leaves or terminal node. Terminal node means we can't split more than that. Just why I am actually announcing that if whenever you went to the interview, they will ask if you know the if you have selected they will give offer which machine learning model you are very well. If you say decision tree, they will use some terminologies to understand how much information, how do good at this to build with this machine decision tree machine learning model. That's why this terminology will be useful. That's why I included everything. Pruning, I already told you. For example, let's take we have used all 10 features. Whatever the unwanted features also used for the splitting. What will happen? Yesterday I gave. If let's take if we have taken greater than 80K is the cheat no, less than 80K is the cheat yes. Dependent variable is the cheat. Greater than 80K is the cheat no. Less than 80K is the cheat yes. We have splitted like this based on the data, each and every point. What will happen if whenever new data point comes with exactly 80K, we can't take that one. For example, not only that one. If we have taken starting point is the this parent and child node, ending point is the this Python I kernel. This is the starting point. This is the destination point. We want to go from here to here travel. What we'll do? If we have taken one is the this is the approach. If we have taken entire thing, all points and like this, whenever the data point comes here or here, what will happen? The route will miss. Due to that miss, we are facing lot of problems to reach the destination. Sometimes we will go for the some other places. That is the misclassification. So to avoiding that type of overfitting means we are giving the one particular route. If is there any change in that particular at any point, we lost the entire information. That's why don't go for the overfitting. We need to give some possible randomness also to the path. Then only we are able to achieve correct classification. For that purpose, we need to split our tree. We need to cut our tree at the decision nodes. Wherever we are able to get classification correctly, we are able to classify correctly. At that node, we need to cut the decision tree. That process is the pruning. So this is the opposite of the splitting. Opposite process of splitting. So pruning is the crucial in this decision tree. Branch and subtree. The subsection of the entire tree is called the branch and subtree. Parent child node also same. Whatever the first node is the parent, we will split into the child nodes like this. Next, decision tree algorithm intuition. Here, what we do for each attribute in the data set, decision tree algorithm forms a node. But the most important attribute placed at the root node. We will apply this splitting for the each and every attribute. But before going to that, first we will select one important independent variable. We'll give it as a root node. That is the main thing. Then after, for evaluating task in hand, we start the root node and we work our way down tree by following the corresponding nodes that meets our condition and decision. That how do we achieve this one? We'll say uh, by using the information gain and Guinea. How it is are will explain. This process continue until we reach the leaf node. Okay, it contains the prediction outcome of the decision tree. Let's take the attribute selection measures. Here, I already told you we have selected important attribute is placed at the root node. How do we select whether it is important or not? We have the two types of measures. Those are the Gini index and entropy. Entropy in the sense we call actually information gain. There, I already told you there might be some fails in the Gini index and entropy. That's why we will use information gain or gain ratio. We'll say about the for the entropy we will why we are measure the entropy. This entropy will useful to measure the impurity of the data point, purity and impurity of the a particular attribute. Here, what we'll do, this is the entropy formula. Entropy equal sigma of the probability of the, we will calculate the probability, and then after we'll check the probability, how much information does it have regarding this particular class. Here, sigma is applicable for the I to 1C. How many number does it have? That many times it will calculate the probability and it will sum. Here C is the number of clauses and P is the probability. Based on the class, what is the probability of the particular attribute. See, but entropy itself, it gives us some misleadings. That's why we will calculate the information gain. We'll say entropy measures the impurity of the given data set. In physics, mathematics, entropy is referred to the randomness and uncertainty of the random variable of X. But in our decision tree, this will useful for to calculate the information gain. Information gain means it is the what is the difference between entropy before split the independent variable and average of the after split the independent variable. That is the how that is the normalization. Here only thing is the normalization. Whenever we use direct value, there may be chance of the some misleading. But whenever we apply some normalization, then it will give the exact whatever we are expecting. That's why here Gini index or entropy, we will go for the normalization. That purpose, information gain is the decrease in entropy. Information gain computes the difference between the entropy before split and average entropy after split. Before first, for example, we will calculate the root node before splitting. What is the entropy? Then after we'll split the root node. Then after again we calculate the entropy of the all splits. So then after what we'll do, we'll differentiate before what is the entropy before split, and then after split we will get the entropy for the each split. We will take the average of those splits entropy and we will subtract. So whatever the value we get, that is the information gain. Based on that information gain only, we will select whether what is the root node and what is the sub node, what is the decision node, like that. So decision tree algorithm uses entropy to calculate the information gain. So by calculating decrease in entropy measure of each attribute, we can calculate their information gain. I don't know whether you people remember or not. Yesterday I have calculated for the ID. There are the 13 records, but we have the 13 different values for the ID in ID attribute. Whenever we calculate the Gini index or entropy, it gives the high Gini index and a high entropy for that particular ID. So there might be, it is a misleading. Actually, IDs doesn't have any information. To avoid that type of failures, what we are doing some normalization, that is the information gain. This attribute is the highest information gain. Highest information gain means that highest importance have that attribute. That means a highest information about the dependent variable this particular attribute have is the chosen splitting attribute at node. So which attribute have the highest information about the dependent variable, will select, we will get a high information gain for that independent variable only. So based on the highest information gain, we will select the split. This is the entropy. There is the another measurement also, that is the Gini index. Here we are calculating by using log values, but here we are calculating 1 minus sigma of the probabilities. So whenever if 1 minus 1 0, that is the high purity attribute. If whenever the probability of the particular by using this attribute, for example, let's take one attribute ID. By using this attribute, we are not able to classify correctly. So that variable get the less probability. Why? Because we are not able to classify correctly. That means whatever the correct class, it will get the low probability for that class. That means low probability. 1 minus very low probability, that is the 1. For example, it's 0, that is the 1. That is the that attribute is completely impure attribute. That doesn't have any information about the dependent variable. Okay, yeah, same. How do we calculate here? Here also we will calculate. Let's see. Gini index says if the random select two items for the population, They must be same class or probability for each. This is 1. If the population is pure. If the population is pure, there must be items, whatever we selected randomly, they must be related to the same class. And probability is also 1. 1 means we are correctly classified. It works with categorical target variables success or failure. It performs only binary split. The higher value of Gini, higher homogeneity, uses Gini methods to create the binary split. So mostly whenever we have the high number of categorical variables in our data set, then this Gini index we will use. Calculate the Gini for subnodes using formula sum of squares probability for success and failure. Then after, calculate the Gini split weighted Gini score for each node of that split. So first, what is the success failure means? If we are able to predict correctly, that is the success. If we are not able to predict correctly the class, then that is the failure. So in this case, discrete valued attribute, the subset gives the minimum Gini index. So select a splitting attribute. So wherever we have the which that was if Gini index is very low means that is very high pure attribute. That's why at that time we have selected that is the splitting attribute. In the case of continuous valued attributes, the strategy is to select each pair of adjacent values possible split point similar Gini index smaller Gini index chosen as the splitting point. That is the main thing. I already told if we are able to predict exactly correctly, what we will get? We will get the probability high. So high means 1 minus, for example, you have take 1 minus 0.9. We are able to predict correctly. So we get the probability for that class 0.9. That means if we substitute that 0.9, what will happen? 1 minus 0.9 is the 0.1. Gini index is very smaller value. So this attribute is the high informative attribute. Based on this Gini index smaller value, we will select the splitting point. Wherever the Gini index smaller, then we will select that is the splitting point. The attribute with minimum Gini index is chosen as the splitting attribute. Okay. Here,
Yes.
actually, yesterday I thought you people have some doubts or some confusion. That's why I'm explaining again. Maybe because if before going to the Python practice, if you repeated again this concept, it will help you people a lot. That's why I have taken this decision. So today onwards, whenever we go to the Python practice, we will repeat the process what we thought at the session of the concept, original decision tree concept or whatever SVM random. Okay. So you
Yes, ma'am.
people will get more knowledge on this.
Yes, ma'am.
Okay. Yeah. Overfitting. This is the main problem with the decision tree. Here, overfitting is why overfitting happens. If we have taken previously, if we have the 100 or 200 features in the sense features, predictors, independent variables, all are same. In decision tree, if we apply the 100 feature selection, whatever in data, we won't get exact data. Exact data means which data is classified the classes correctly. We won't get that data. In data, there might be chance of some outliers. There might be chance of some random noise. There might be chance of some trend. This type of patterns will present in the data. Let's say uh, we are going to the numerical split. We are going to the numerical to split the numerical attribute. If that, for example, let's take some randomness and some outliers presented in that particular attribute. Randomness means the class, there might be, for example, let's assume 20 to 100. We have the different values from 20 to 100. What two classes, class 1 and class 2. 10 to 15 or 10 to 21 or 22. 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22. All are related to the class 1. Again, 23 is related to the class 2. Again, 24 to 30 related to the class 1. Here, due to this 23 point which is related to the class 2, due to that there might be chance to split. For example, if we split between the 22, what will take? we will take exactly 22 is the class 1, remaining are class, 23 is the class 2, remaining are the class 1. So again, we have the 30 to 40 class 2, 40 to 50 class 1, 51 is the class 2. Again, 52 to 55 is the class 2. Sorry, 51 is the class 2, 51 or 2 to 55 is the class 1. So these are the, due to single value, the class will be varied. That type of randomness, if presented in the data, what will happen? We will take 10 to 22 is the class 1, 24 to 30 is the class 1, 23 is the class 2. Whenever the point, maybe there might be chance, this is the numerical data. If we get the value 23.5 or 22.5, 22.8 like that, at that time we will feel confused due to that one, whether it is belongs to class 1 or class 2. That is the problem with randomness. For example, let's take the outlier, that is the 100, 200, but the values, we have the only 100 till 100, but we got the one outlier 200, 200, 220, like that, 2, 3 values. What will we have? For example, if we have the 95 to 100 is the class 2, let's assume 95 to 100 is the class 2. In outliers, 20, 200, 201, 204, 205, those are the 4. Out of those 4, 3 are class 2. 95 to 100 class 2. Those 3 are class 2. 1 is the class 1, but that is middle one, 201. 202, 204, 205 is the class 2, 201 is the class 1. Due to that outlier, we need to split again. So whenever new data point comes between the 100 to 200, we can't say whether it is belongs to class 2 or class 1. Why? Because there is lot of variation between the 100 to 200. The difference is very highest. Let's take, if we have the 100 is the class 2, 200 is the class 1, 201, 203, 205 is the class 2 again. So 200 is the class 1, 100 is the class 2. What is the classes between the values 100 to 200? We don't have any data in the training data. Whenever test data have the 110 or 120, 100 is the class 2, 200 is the class 1. How do we say whether it is related to these 110, 20 is related to the class 0 or class 1? So if we give the 200 class 1, if we split data points till this end, what will happen? Sometimes we are it gives that good, why? Because in training data we are splitting till 200, 201, 203. That's why it gives the good results for the training data. But whenever the test data have the 110, 120, what will happen? The test accuracy will become decreased. That is called as the overfit. That type of problems are facing with decision tree algorithm. For that purpose, we need to do way to terminate our tree to make a good decision. But if we want to say there is that pre-pruning, post-pruning. Pre-pruning means before building a model, we will split after 10 splits, after 20 split, you can terminate the decision tree. But it's not possible to identify that type of pre-pruning decision. We don't know how many, now where it gives the good classify by seeing the data. Post pruning means after completely build that decision tree, again it will become as a cross here we will use the cross validation. You already people know the cross validation, k-fold cross validation. What here k is the important. Whatever the value we provide for the k, that many decision trees it will build. Based on those decision trees, it will get to conclude where to split. It will automatically conclude based on the classification, based on the information loss. It will calculate the error for the each and every tree. It will terminate the wherever decision nodes are presented in the decision tree. Okay, that is the pre-pruning and post-pruning techniques. So this is the overall concept. Let's check how it works. You people already know this pandas library is for to play with the data frames. This numpy is the play with models, whatever the numerical data. These 3 are the visualization libraries.
Yes, ma'am.
Yes, this is the warnings. If while using some libraries, due to some new features, due to some old libraries, if we are using some old libraries, it will once you have the latest libraries like that, so you can go for that library. That type of warnings we need to avoid. That's why that one. Here I have taken car evolution CSV. It have the 1700 records. I'm assigning some columns to these names to this data frame. Now check the what is the data. This is the buying, mind, doors, persons, boot, logbook, safety classes. And how many classes are there? Let's check. All are objects. There is no numerical data. So these are also categorical data. That means let's check the yes. Here we have the two frequency 432. So two classes. That's why that's the reason it consider doors and persons are also categorical data. How many different classes are presented in the dependent variable? Good, very good. What is this ACC? Accuracy or inaccuracy? Access, unaccess, I think. There are the four different classes presented in the data. Let's check, is there any missing values? No. So what we need to do? We need to separate independent variables and the dependent variable. Here our dependent variable, what the name we have assigned, that is the class. That's why I am dropping while taking the independent variable. I am assigning this df class for the dependent variable y. Then after to measure the model performance, we need to split our data. People, this splitting, this feature selection, this everything I thought 4 or 5 times while building linear regression, while building logistic regression, while building PCA, while building cluster. That's why I'm not go through uh, again through these concepts.
Yes,
You
ma'am.
people, yeah, you people know why we are splitting, why we are assigning X variable for the independent variables, Y
Yeah.
variable for the dependent variable. Here, see, I already told you, machine learning is the mathematical equations, so totally depends on the mathematical. So here we have the all our categorical data. So we need to encode. Previously, I introduced this concept as a dummy variable. You people have the, did you remember dummy variable? Dummy variable is, for example, age have the male, female, transgender. While creating dummy variable, what it does, instead of a single column, it will divide into the three columns. That is the gender male, gender female, gender transgender. What will if the data point is if the person is male, it gives one for the gender male, zero for the gender female and transgender. So based on the person gender, it will gives one for that gender, zero for the another gender. Okay, that is the dummy variable concept. Same here we are doing. Uh, that is just for your understanding. Here we have the one is the categorical encoders. Encoders means it gives the some random values. For example, this buying, how many values does it have? Two, high and very high. So this is the ordinal categorical. You know the categorical two types, nominal, ordinal. Nominal means whatever the names, IDs, some other gender,
which
location.
don't
These
have
are the
a real
nominal.
meaningful thing.
Yes, these are, for example, based on the location, based on the name, based on these things. Everyone have the high same priority. There might be no difference between the one pattern to the another pattern. But coming to the ordinal, movie ratings, reviews what we are providing, stars what we are providing, they those are also categorical, but the difference between the one point to another, for example, we have the 10 different categories in the particular movie ratings, 1 to 5. So five different but the difference between the category 1 to category 2, there might be one. It is the ordinal way. It have the some meaningful difference. That is the ordinal categorical. That type of ordinal categorical data is this one. Let's see, low, high. So low is the compared to low, high have the some. The difference is the high is the major one, low is the but so what we'll do, high, very high. There may be some difference. So this is the ordinary categorical data. That's why we are encoding like this. We are for example, sorry, instead of creating dummy variable, it created as a like this. So whenever one, that means very high. Whenever two, that is the high. Is that yes? Three for low, four for medium. So it gives the one numerical value for the each and every one. For example, the very high is the first category we found, that's why 1. Low is the second we found, that is the 2. Again low, sorry, high is the 2, low is the 3, medium is the 4. Based on the categories present in the data point, it assigns the 1, 2, 3, 4 values. Just here also, this is the category. We are not changing the data type. Data type is always object. Whenever we change our data type to numerical, then that time it will consider the difference between the 1 and 2. Whenever data type of the particular attribute is object, it consider it as the categorical. Just for instead of using this very high, we are using some numerical values. That's it. That is the category encoders. Here we are, for example, last time was for example, my name is Anuradha. But most of the people use Anu instead of Anuradha. What we called Anu is the alias name. Same, just like that. Instead of very high, we are using here 1. That is the representation of the very high. That's it. That's what a category encoders converted string to numerical data.
Ma'am, as per this, the medium should be assigned as 3, right?
Yes.
Medium should be assigned as 3, and for 4 it should be assigned as low.
No, low is the 3. See, what we'll do? For example, let's take we want to join into one yoga class, or we want to join into the one institute for the to take the course. What will they do? They will give some random ID. That is the random ID for the each and everyone. Whoever first join, they will give the 1. The next join, they will give the ID 2. The third join 3. Till after 99 members, the 100 member join, they give the number 100 for as a ID for that guy. Is that right? How
Yes.
roll numbers give at the classroom? Just like whatever the data point first entered into this category encoder, they give the 1, then after 2, then after 3, then after 4. That's it. Why? Because this is categorical data. This is categorical data. There might be no difference between this one.
Okay, if low will be there in the first one and very high will be in the last one, then low will be assigned as 1.
No. See, actually, if we want to do logical, it will consider like that. Coming to the machine learning concept, what it will do? Is it perform, for example, let's take, if we have the total numerical values, then we will consider the which one is the highest value, which one is the lowest value, which one is the middle value, like that. Whenever categorical, we will use some categorical data for to build the model. Categorical data doesn't have that difference, but we will use that information to build model. How? Just based on the category, we will decide whether it is, for example, based on the if we want to predict house price based on the location. For example, we provided the records. Hyderabad is the 20 lakhs house. Bangalore is the 25 lakhs. Chennai is the 15 lakhs, like that. So, whenever we building model, what we'll do? Hyderabad is 1, Bangalore is 2, Chennai is 3, like that. But Hyderabad is the middle one. But whenever Hyderabad one present, it understand Hyderabad. So, by repeating Hyderabad is the 20 lakhs Hyderabad, 20 lakhs Hyderabad, 20 lakhs 10 to 4, 20 times, model automatically gain that information. So whenever one is the Hyderabad, it presents, it might be chance to the 20 lakhs. Whenever Chennai, it is the 3. So whenever we are provided 20 or 25 records regarding Chennai with 15 lakhs, what will based on that 3, it will understand it is Chennai. So it is the maybe 15 lakhs. Like that, our model will We are tuning our model. Let's take when a baby born, he don't know any word, but
Mhm.
while growing, how do he learn? He learn about the who is his father, who is his mother, what is his name, how to walk by seeing others, by listening other words. He can understand. Okay, whenever we feel hungry, we say this is the word hungry. Whenever we feel thirsty, so we need to ask our mother, mom, I'm feeling thirsty. So how many times he will listen before going to say, amma, I'm feeling thirsty. So how do he get that information? Does he is calculating any mathematical expression? Does he calculating anything? No. By listening, he will get that idea. Yes, this feeling is the thirsty. She is the my mother. Everyone says your mother, your mother, your mother. So she is my mother. Everyone saying, what are you doing, your son? What are you doing, your daughter? So I am her daughter and son. By listening, by same concept, that is the models also doing whatever human doing. How this is the main concept before the artificial intelligence. How we are learning, how our neural system works in the brain. That concept we need to be using the artificial intelligence model. So what we are doing by just we are giving these all are categorical data, doesn't have any difference. So what we'll do, for example, let's take the movie rating 1, 2, 3, 4, 5. There might be some
Mhm.
difference 1 to 2, 2 to 3, 1 to 5. What is the meaning by 1, 2, 3, 5? 1 means fail, 2 means okay, it's okay to watch one time. 3 means average hit. 4 means super hit. 5 means super duper hit. But while building model, it won't consider with whether it is fail, whether it is average. Based on the, for example, based on the super duper hit, does it gives the high priority for that attribute? If it bias to that attribute,
No.
based on the movie hit, it won't give any priority for that class. While building model will take say give same priority for the uh, uh, which movie fails, average movie, same priority for the all movies, whatever the rating 1, 2, 3, 4, 5. So for that purpose, just we are encoding. That means instead of LOW string alphabetical letters, we are converting into the numerical digits. That's it. Just for computation. Why? Because computer will understand only digits and models will work on the digits only. That's why we are giving these values. See here, through sklearn, I am importing decision tree. First, we'll check. We have the two measures for to build the decision tree. One is the Gini index, another one is the entropy. First, we'll check with Gini. So here I gave the Gini max depth, random state. Random state you already know. So max depth means uh, so we this is the pre-pruning. So we are saying pre-pruning. So the max depth of the decision tree is three nodes till three nodes. So then after we give the extend and wide range as the input for the model. Then after we'll try to predict, check the accuracy. That is the 80%. So here whitest is the true classes. By using the whitest, we are calculating the accuracy. How many values predicted accurately? Let's check what is the train test accuracy and test accuracy uh, to identify the whether the classification, whether the model goes to the underfit or the overfit. See, if train and test accuracy both are very low. That means train and test accuracy both are very low, under less than 50. That means underfitting. If the train accuracy is very high, but test accuracy is very low, that means overfitting. But let's check here training and test score both are training is the 78, testing is the 80. So there is no much difference between these two, and both are very high. Not it is not less than 50 or like that. 80% is the good accuracy. So uh, this this model gives the good results. This model don't go for the overfitting and it won't go for the underfitting based on these results. Till that, but till now, what we are saying, decision tree build the decision one tree. If we want to check how it takes that one, for example, which is the root node, which is the sub nodes, what are the some other nodes, this will be useful. X5, X5 is the independent variable. So this is the it takes it as the root node. Then after it split into the two binary split. Why? Because all are categorical. Categorical here I already told you. Guinea is the binary splitting for the categorical data. See here. Here I told about the yes. It works with the categorical data, Guinea index. So it works with the categorical target variable, success or failure. It performs only binary splits. That's why it splits here binary splits for the categorical data. Okay. If you actually for now we have used only 6 or 7 attributes, so it might be that much problem. Whenever we use the 100 features or 20 or 30 features, at that time if we want to select a particular feature selection based on the, actually we don't need to do that. Why? Because we have the pruning technique, so we will cut the decision tree through the pruning only. That's better instead of checking each and every independent variable whether it is informative or not. Okay.
Yes,
Yeah,
ma'am.
here actually here I gave the x5. This is the, we don't know what is x0, what is x5, like that. If you people want to see particular attribute exactly, attribute name, you can use this one. Safety. This is the person's attribute. This is the buying attribute, like this. Okay.
And ma'am, when we were calculating the overfit and underfit, uh, we were looking at right means in both the situation, overfitting and underfitting is not good for our model. So
Yes.
we came into the conclusion that it should be in between, so that we can get a low bias and low variance thing.
Yes.
Uh,
Underfitting means low bias. Overfitting means uh, sorry. Underfitting means high bias. Overfitting means high variance problem.
yeah, so it
Yeah.
should be both means it should be in between, that means we should get a low bias and low variance. So here we are getting both of the things high, means underfitting also is high and overfitting is also is high.
Where?
So means here the training set score when we were calculated, right?
Yes, we have calculated training score is 78 and test score is 80.
Yeah, so is it high, right? Means it is high or
See,
it,
what is underfitting, what is overfitting? Underfitting means both training error and validation error, both are very high. Is it right?
yes,
So
yes,
underfitting means both training or testing errors are high. Training
yes.
testing errors are high. That means training accuracy and testing accuracy will come very low. This is the accuracy. This is the accuracy 78% training. This is the accuracy 80% is the test score. This is the test X test Y test. That is the, this is the accuracy. Here
Okay,
both accuracies are very high. That means training and test errors are very low.
okay,
Yeah.
okay.
Coming to the overfitting, here training error is very low, but testing error is very high. That means training accuracy is very high, but testing accuracy is very low. But coming to here, testing accuracy is also near to the training. Both are high. That means there is no overfitting.
Okay.
That's what. If, for example, let's take if we have the training accuracy 78%, but testing accuracy are 40, 50, at least 60.
Mm-hmm.
Then training accuracy is very high, testing accuracy is very low. That means that is the overfitting. If the
Okay.
accuracy of both training testing are less than 50 or less than 60, then it is the underfitting. But here we did not observe that type of difference.
Okay.
Yeah, that's so till now we have checked with Gini index. There is the one parameter that is the criterion parameter. Here we will say whether shall we want to use entropy method, entropy measure or Gini measure to build the decision tree. That's it. But both are to identify the root nodes, sub nodes, and the decision nodes. Here, the model building is always same. So we will collect data, we will check the null values are presented or not, categorical variables are presented or not, what is the variation through the describe method. If null values presented, we will handle that null values. Then after we'll assign some normalization. Sometimes if we want to apply any PC and anything, we will do some normalization. Till this is the data pre-processing. Coming to the model, what we'll do, we'll give the X train and Y train. We will split data into the train and test to measure the performance of the model. So whenever we build model, we'll first give the train data to build the model. Then after we'll use test data to predict the expected predictions. Then after we'll check the accuracy. This process is same, same for all model through the Python. What we are performing is same. But why I'm saying these concepts means if you don't know this concept, we don't know what we'll do, what we will feel. So there might be same way to build a model. Why not to go decision tree? Why need to we select logistic regression? If we all are same machine learning models, if I will use same model for the all case studies. If we feel like that, we won't get good accuracy while building model. So if we know the different concepts, based on that concept, we will change model building. Here, the Python script is same for all, but the algorithm in sklearn, they will use some algorithm for decision tree. They will use some algorithm for the logistic regression. Based on the logistic regression concept, they will build that algorithm. Based on the decision tree concept, it will build these algorithms. So those are the different. If you know that concept, then you will understand why you are using this decision tree library instead of logistic regression library.
Okay.
So again, whenever you use entropy, we are getting the same result. So here also it has taken same. Here let's see. Here also it takes first safety is the node root attribute, persons is the sub node, buying is the subsection node or decision node. This is the decision node. Then after we'll go for the directly classification. So same here also, and whenever we use entropy, it takes the safety is the root node, persons is the sub node, this is buying is the decision node, like that. Uh, this is the confusion matrix. Confusion matrix is why it will useful. I already taught you. Sometimes this precision is more have the high priority compared to recall. So based on the priority of the recall precision, sometimes instead of precision recall, accuracy is become the uh, accuracy will have the high priority compared to precision recall. So based on this confusion matrix, we need to try or we need to improve our model. For example, let's take here we have the precision correctly, but there might be nearly 60%, 60 samples are misleaded from this one. So what we'll consider, we'll take this is the high priority. Whenever if we want to increase 80 to 85 or 90%, what we do, we'll concentrate on this recall to improve the model accuracy. But by seeing this confusion matrix, we can't calculate. By taking calculator, don't need to calculate the what is precision, what is recall. So we have the one is the classification report function. That function will gives you what is the precision, what is the recall based on the class. Dependent variable have the four classes. That is these are the four classes. Based on the class, it gives the precision recall. Okay.
Mhm. Yeah.
Results. If you have any doubts, I already told you. If you people want to go deep and deep in this decision tree, you can go through these links also.
Okay.
Yeah. If you whenever you go to the real time project at that time, this notebook will give you uh, basic skeleton for to build the decision tree model. If you face any problem at that time, you go through these reference links. It will give the more. For example, see here I gave the information gain in so it will explain through the each and every mathematically. If you people want to, for example, instead of doing as a data scientist, if you got the opportunity to develop the machine learning models. At that time, this will be useful to you. As a data scientist, whatever the developers developed libraries, we will use. But if we want to work as a machine learning model developer, for example, but they have a lot of pre-trained models, you will build some pre-trained models at that job. Before you want to go that job, at that time these will be useful. This mathematical intuition. For now, for a data scientist, you don't need this much of information. Okay, guys, any doubts?
No, ma'am.